Solving radical equations. A radical equation in one variable is an equation in one variable that contains a radical with the variable in the radicand. Squaring property of equality. If a and b are expressions, then all solutions of the equation a equals b are among the solutions of the equation a squared equals b squared. That is, the solutions of an equation are among the solutions of the equation obtained by squaring both sides. In this example, solve by squaring both sides of the equation. Square root of x equals 5. So if we square the square root, we'll end up with just x. But for this to remain an equality, what I do to one side, I have to do to the other. So I also have to square the 5. X equals 25. If I were to check this, the square root of 25 should equal 5. 5 equals 5 is the solution. Solving radical equations. If a proposed solution of any type of equation is not a solution, it is called an extraneous solution. Checking proposed solutions. Because squaring both sides of a square root equation may introduce extraneous solutions, it is essential to check that each proposed solution satisfies the original equation. In this example, solve by squaring both sides of the equation. The square root of x equals -2. Squaring both sides, my result is x equals 4. -2 times -2 is a positive 4. Then I want to check the square root of 4 should equal -2. The square root of 4 is 2. 2 does not equal -2. So my answer is really no solution. Power property of equality. If a and b are expressions and n is a counting number greater than 1, then all solutions of the equation a equals b are among the solutions of the equation a to the n power equals b to the n power. That is, the solutions of an equation are among the solutions of the equation obtained by raising both sides to the nth power. In this example, solve by using the power property of equality. The cube root of t equals -2. So the power property says that I can take both sides to the third power and it remain an equality. So the cube root of t cubed is t, and that equals -2 cubed, which is -8. Checking. The cube root of -8 should equal -2. Since it's a cube root, I can take the cube root of a negative number. -2 equals -2, so my solution works. Solving radical equations. Solving a square root equation in one variable. To solve a square root equation in one variable, 1. Isolate a square root term on one side of the equation. 2. Square both sides. 3. Repeat steps 1 and 2 until no square root terms remain. 4. Solve the new equation. 5. Check that each proposed solution satisfies the original equation. In this example, solve by using the power property of equality. 5 square root of x plus 2 equals 37. First, we want to isolate the square root of x. I want to do this the same way I would solve an equation for just x. First, by subtracting 2 from both sides. 5 times the square root of x equals 37 minus 2, which is 35. Then dividing both sides by 5, the square root of x equals 35 divided by 5, which is 7. Now I am ready to square both sides to get rid of my root. X equals 49. So either my solution is 49 or I have no solution. I need to check. 5 times the square root of x, which is 49, plus 2 should equal 37. The square root of 49 is 7. 5 times 7 plus 2 should equal 37. 5 times 7 is 35, plus 2 should equal 37. 35 plus 2 is 37. So my answer is 49. In this example, solve by using the power property of equality. The square root of 5x minus 7 plus 7 equals 3. The first step is to isolate the square root. I need to subtract 7 from both sides. I have the square root of 5x minus 7 equals 3 minus 7 is negative 4. Now I'm ready to square both sides. The square root of 5x minus 7 squared is 5x minus 7. And that equals negative 4 squared, which is 16. Adding 7 to both sides, 5x equals, which is 23. Dividing both sides by 5, x equals 23 divided by 5. Now I need to check. The square root of 5 times 23 divided by 5 minus 7 plus 7 should equal 3. 5 times 23 over 5 is just 23. The square root of 23 minus 7 plus 7 equals 3. 23 minus 7 gives me the square root of 16 plus 7 should equal 3. The square root of 16 is 4. So 4 plus 7 equals 3. And 4 plus 7 is 13, which does not equal 3. So this is an extraneous solution, which means this problem has no solution. In this example, solve by using the power property of equality. The square root of t plus 10 equals t minus 2. Because my square root is isolated on the left, my first step is to square both sides. On the left, the square root and the square cancel, which leaves me with t plus 10. On the right, I need to remember that t minus 2 squared is the same as t minus 2 times t minus 2. And I can use FOIL to solve this. So on the right side, I have t squared minus 4t plus 4. Because it's t squared, I need to set this equal to 0. So 0 equals t squared. I have to subtract t from both sides. Minus 4t minus t gives me a minus 5t. Subtracting 10 from both sides, 4 minus 10 is a negative 6. Now I need two numbers that multiply to be a negative 6, but add to be a negative 5. T minus 6 times t plus 1. Setting each of these equal to 0, t minus 6 equals 0, which means I have t equals 6. Or I can set t plus 1 equal to 0, which gives me t equals -1. Checking, I'm going to start with t equals 6. So I have the square root of 6 plus 10 equals 6 minus 2. 6 plus 10 is 16, and the square root of 16 is 4. 6 minus 2 is 4. 4 equals 4, so t equals 6 is a solution. Now I want to check t equals -1. So I have the square root of -1 plus 10, and that should equal -1 minus 2. -1 plus 10 is 9. The square root of 9 is 3. So that should equal -1 minus 2, which is -3. And 3 does not equal -3. So -1 is an extraneous solution. Our only solution for this problem is 6. In this example, solve by using the power property of equality. Cube root of b plus 7 equals 3. I need to cube both sides. The cube root of b plus 7 cubed is b plus 7. That should equal 3 cubed, which is 27. Subtracting 7 from both sides, b equals 20. Checking, the cube root of 20 plus 7 should equal 3. 20 plus 7 is 27, so I have the cube root of 27, which should equal 3, and the cube root of 27 is 3. So b equals 20 is my solution. In this example, solve by using the power property of equality. The square root of 12x plus 13 plus 2 equals 3x. Because the square root has a plus 2, I have to get rid of that first. Subtracting 2 from both sides, my result is the square root of 12x plus 13 equals 3x minus 2. Now I can square both sides. The square root of 12x plus 13 squared is 12x plus 13. And that equals 3x minus 2 parentheses squared. So my result is 9x squared minus 12x plus 4. Because I have an x squared, I need to set this equal to 0. 0 equals 9x squared. Since I have a 12x on the left, I need to subtract 12x from both sides. Negative 12x minus 12x is negative 24x. Then I have a 13 on the left. Subtracting 13 from both sides, 4 minus 13 is negative 9. First, I want to factor out my greatest common factor of 3. So 0 equals 3 times 3x squared minus 8x minus 3. Since it's times, I can divide both sides by 3, which will give me 0 equals 3x squared minus 8x minus 3. Now I'm ready to factor, so I bring down my 0 equals, and I'm going to have two parentheses. A times c, 3 times negative 3 is negative 9. My b is negative 8, and my a is 3. I need two numbers that multiply to be a negative 9, but add to be a negative 8, which is going to be 1 and negative 9. Negative 9 over 3 reduces to negative 3. In one parenthesis, I'll have 3x plus 1. In the other parenthesis, I'll have x minus 3. Now I can set each of these equal to 0. 3x plus 1 equals 0, or x minus 3 equals 0. Going back to the 3x plus 1 equals 0, subtracting 1 from both sides. 3x equals negative 1. Dividing both sides by 3, x equals negative 1/3. X minus 3 equals 0, adding 3 to both sides, x equals 3. Now I need to check both answers to see if either of them or both of them are extraneous. So for my check, I'm going to start with x equals negative 1/3 of the square root of 12 times negative 1/3 plus 13 plus 2 equals 3 times negative 1/3. 12 times negative 1/3 is a negative 4, so the square root of negative 4 plus 13 plus 2 equals 3 times negative 1/3 is negative 1. Negative 4 plus 13 is 9. Square root of 9 plus 2 equals negative 1. The square root of 9 is 3. 3 plus 2 should equal negative 1, but 3 plus 2 is 5. 5 does not equal negative 1. So we know that x equals negative 1/3 is an extraneous solution. Now we need to check 3. So for x equals 3, I have the square root of 12 times 3 plus 13 plus 2 equals 3 times 3. 12 times 3 is 36, so I have the square root of 36 plus 13 plus 2 equals 3 times 3, which is 9. 36 plus 13 is 49, so I have the square root of 49 plus 2 equals 9. The square root of 49 is 7. 7 plus 2 should equal 9. 7 plus 2 is 9. 9 equals 9, so I do have a solution in x equals 3. Solving radical equations. To solve a radical equation with a square root, I isolate the square root, then square both sides. The power property of equality says that regardless of the root, I can still solve that equation. So if I have the cube root of x equals 4, I can cube both sides and still find x. Anytime you're dealing with radical equations, always make sure to check your answer because you can have extraneous solutions.